So what exactly are logarithms? Before we go there, let's talk about exponents. And I think most of you have already know what exponent is. So let's say there is this value a raised to power x is equals to n, right? So we say, so what does this mean? There's a number a which we call base, when powered by x, which is we call exponent, gives you a number n, right? Example, 2 raised to the power of 5 gives you 32, right? We say base when, which we call power or exponent, give you a number 32, right? Now let's understand how and these exponents is related to logarithms and what does we mean by logarithms. So we said a raised to power of x is equals to n, right? Where a is equals base, x is a power or exponent, and n is the value, right? Now think in terms of algorithms. So let's define this as a value of log n to the base of a equals to x. And these two means the same things. Like this implies this and this implies this. So a raised to power of x n in the logarithmic form is written as, so again this is base, this is a number, and this is an exponent, right? So if you have this rule, it says log n to the base a. So how this is pronounced? This is logarithmic of number n to any base a is equals to x, which essentially means a raised to the power of x is equals to n. Got it? Now let's talk more about this function. So let's say if 2 raised to the power of 5 is equals to 32, then we can say log of 32 to the base 2 is equals to 5. Right? Or let's say 2 raised to the power of 1 by 99 is some number n. Then we can say log n to the base 2 is 1 by 99. And there are ways to find these values, which is the logarithmic tables that makes your life solving these numbers easier. Right? Let's take another example. Let's say 2 raised to the power of 1 by 2 is 1.414. This implies log 1.414 to the base 2 is equals to half. So a, remember, there's a base a, which is the same as base a. X is an exponent, which is also an exponent of the power here, is equals to number n. So log n to the base a is equals to an exponent. So you have seen log n to the base of a is equals to x. However, there are certain constraints on these values for log to be valid. And what are they? So one is n has to be greater than 0. You cannot define a log of a negative number. So log of negative number is not defined. Similarly, a is greater than 0. So a has to be positive, and a does not have to be equals to 1, should not be equals to 1. Right? So these are the three elements: n greater than 0, a greater than 0, and a equals to 1. These three conditions needs to be satisfied for a log of any numbers to be a defined or a meaningful number. Right? Why is this so? Before we go into this, we'll solve some of the problems and then we'll see why this is an important consideration or an important element to be true. Let's see in the next video why these values are important, and also let's try to solve very basic problems using logarithms.